My name is Lily. I'm a front-end engineer. I'm here to do Leedcode questions in JavaScript. Today I picked question number 3 with the title of longest substring without repeating characters. The difficulty for this question is actually medium. So as the description says, given a string s, find the length of the longest substring without repeating characters. So let's go through the examples. Example number 1 says ABC, ABC, BB, and the output will be 3, which makes sense. So far, like the things that we are seeing, the length of them are 3. Example number 2 is an input with the length of 5. However, all the characters are the same. So basically, as soon as the substring goes more, the length of the substring goes more than 1, there will be duplication. So pretty straightforward. 1 is the right answer. The next one, example number 3, is PWW KEW, which is the output will be 3. Again, you can see the pattern. And example number 4 is an empty input, and so the output will be 0, which like it's obvious because no substring can be longer than the original string, and while the length of the original is 0, the length of the substring can be more than 0. And constraints and clues are showing that the length for the input can be 0, which is an empty string, and the maximum will be 5 times 10 power 4, which is too big to do recursion. Recursion will cause you a stack overflow issue, so don't go that way. The other clue will tell you that the input can contain letters, digits, symbols, and spaces. So as you see, what I'm seeing here is basically a sliding window algorithm samples. So for the sliding window algorithm, as you might know, we need 2 pointers. One is the one pointer that holds on to the beginning of each window, and the other one, the second pointer, which is holding the end of the substring, and it helps to expand that window. So windows here basically represent substrings in each input. And like in the other thing that we need is a tracker, which is maximum length, and that's exactly what we are looking for here. So we want, like every substring that we find, we want to make sure that compare it with whatever we had before to keep track of the maximum and compare those two and hold on to the longer one. To do that, to make sure and to get the substring with the duplication, to keep track of duplication, we need a hash map basically. So the hash map will track everything and updates everything to make sure, and you can compare your substring that you are working on at the moment and the characters in to make sure there is no there is no duplication, and if there is, you have to start a new substring. Let's go through the steps on example 1. Like here, like both pointers will start from point 0 because beginning and end. Will be the first substring will be 8, length will be 1. It meets the criteria, which is no duplication. We expand, put the second pointer incremented, and we expand our window. Will be AB, the length will be 2, and no duplication, pretty fine. And then we expand the window. Second pointer goes to C, the length will be 3. No duplication, everything is fine. We expand again, and it will be ABCA, which we see there is a duplication here. By the time that we hit the duplication, it means we have to start a new substring. To do that, first of all, we want to make sure that first thing that after finding a duplication is we want to make sure this duplication we found in our hash is like the index of it is among the in the range of the current substring that we are looking at. Like here, it is, because it's the index of this, the substring, the index we want to find will be 0, so A. So first thing we have to keep, because after this we are going to start a new substring. We want to make sure that we hold on to the maximum length. You check the compare the length, keep it in the max length tracker. And second part is like we have to move the starting point to the next character after the previous duplication. This helps us to slide our window and start a new substring. So for like here, the previous duplication was A, which is 0, so we're gonna increment it and like move it to the next one, so it will be 1. So start from B. So here will be BCA. Again, the length will be 3. We expanded BCAB, again duplication. We take the exact same steps, start from CAB, 3 again, and we expanded 4C again is a duplication. We take the same steps, then we're gonna ABC 3 again, and then when we go to B, this time actually at this time our previous duplicated character will be B, which is not at the beginning of the current substring. So just make sure that wherever it is this, we have to start from the next character. So here B was a duplicated character, so we start from C and B. CB will be 2. The length is less than what we had so far, so we're gonna expand CBB. Duplication again, and again the previous duplicated is not the first character, so we want to start from the character after, which will be the which will be the B, the only B we have, and that's the last substring, which the length is 1. And when you compare, that doesn't matter because we already have maximum 3, and 1 is less than that. So let's get to the coding here. Okay. So we get that like what we need here. We need the variables to help us to make to solve this problem is first the 2 pointers. So I'm going to have the start index, which holds on to the index of the beginning of the window. The next one will be I'm gonna call it car index. That is the last index of the last one, in the current substring, and it helps to expand the window. So at the beginning will be 0. And the next thing that we need is the max length tracker. I'm gonna call it max length. So will be 0 because we don't have any. And last will be the hash map, but that we are checking and tracking our duplication with it. So I'm going to call it char to index, since that my hash map will connect the character to the index of each character. So, and to go through our okay, let me clean this up. Make it more readable. Okay, to go through our input, we have to make it like we know that to go through the input, we can keep track of the last first of all, I'm using while because while loop is faster, and the second thing is like to stop to this loop, I'm going to check the current index because I know the current index is the one which goes through the whole input, and so I want to make sure that it's always smaller than the length of our input. So the next step is like we have two steps that no matter what we have to take them. First is like we have to create update our hash map. So to update that, I'm going to update that, I'm going to add a key and the index of that. Key, which is the character of the character in the input, and assign the index of that character as a value. So to get that, char add car index, and I'm going to give it the value of car index. So as you see, character to index. And what else I have to do? I have to expand, expand our just move my current index and expand it. So current, to do that, I just increment the current index. So these are the steps that we have to take no matter what. There are and the only situation that makes us to take extra steps will be the time that we find a duplication. So to check the duplication, to see if we have a duplication in the current index, what we have to do is we check for a condition. And what will be the condition is first condition, we have to check if it's the current index, the current character we are checking, the index of it, that already exists. So to do that, let's actually keep it the car char. I'm gonna call it car char, and the car char will be the add car index. So the car char will hold on to the character, to the character that we are looking for. So we want to make sure if it exists, if that key, that specific character already exists in the blueprint. So what we have to do is car char in char index. So it checks if it already exists in the in our hash map. The other condition that we have to check is actually making sure, because we are not deleting anything from our hash map, we don't delete anything, we don't remove anything, it's just getting updated. So there might be the same character in our hash map which shows duplication, but the index of it is not in the range of the current substring we are looking for. So for example, there might be from previous substring that we were checking. So to make sure that this duplication is actually belonging to the current substring, we're going to check that if the index is in the range of that specific substring that we are looking for. So for that, start. Oh no, actually we want to check char to index. Character of car index is actually bigger or equal to the start index. So in that way, make sure it makes sense that it's after the start point, so it makes sense. It shows that it's in the range of the current substring. So after that, all we have to do there are two steps that we have to take here in case of the duplication. First, we have to because this is the before starting a new substring, so we have to make sure that we are keeping we have the track of the maximum. So first we have to check and compare the length of the current substring we have with what we had before, and make sure the max length contains the maximum so far. So to do that, I'm going to use max method. method, and the comparison will be between the max length that we had already and the length of the current substring, which is pretty straightforward. We have the beginning of it and we have the end of it, which is the current index, and the only thing we have to do is just subtract them to get the length of it. Start index. Okay. Next, after after that, all I have to do to start a new substring and slide my window. To do that, I move the starting pointer to the character after the previous duplication. So to do that, pretty straightforward. So I want to make sure car to index of the car char plus 1. So it moves it to the next character after the previous duplicated character. So this loop goes in until we get to the end of the input. When we get to the end of the input, it means like we have to get like the loop is over. We have the last substring and a maximum so far before the last substring. To make sure that like we check the latest length as well, so we have to compare and do the same thing that we did here. So I'm going to use max, so max length, and again car index subtract from a start index. Yeah, this should work. Let's try it. I'm doing something wrong. So we check for the current index, car char in the car to character to index. So if its character to index is bigger than start index, yeah. So here I made a mistake. This is char. This should work. Yeah, perfect. So let's submit. The submission of Leedcode will actually do the code for multiple examples with different sort of expectation and like if there are little details that we have to make sure. So this actually went through. All the examples came out successful, and the runtime is 128. Actually, I did this for submit this solution before, and like there are a little bit like a couple of milliseconds different, but anyway, so far I had faster than 51% of people submission, and memory usage will be 54 less than submissions so far. This is if anyone knows a better solution that is faster than this, I'm actually appreciating if you let me know. I hope you liked this video and you found it useful. There's nothing else left to just ask you. If you like it, please press like, and if you found it useful, please subscribe. Hope to see you guys at the next Leedcode. Bye.